we're on our notes book, we're on page 21, and we've got basically 2 exercises to go. So today we'll go through factorising cubics, and on Thursday we'll finish the unit by looking at graphing cubics and quartics. Now the first thing I want to draw out is, this one isn't in our notes book, but I do want to emphasise this skill because I'm a bit uncertain about our expansion ability. So I want to just go through this. I'm going to demonstrate this skill up here, and you guys will have an opportunity to practice it in a moment. I think we're probably pretty comfortable expanding 2 brackets, but I just want to draw out how we could do it if there's 3. Okay, so when there's 3 brackets like this, basically the order of multiplication doesn't matter. That's a principle of mathematics, right? So that means that 2 times 3 is the same as 3 times 2. The order in which those are written doesn't matter. Now what that means is this, the way this is written, you could write it in any way. We could put the x take 3 term at the front, times x plus 2 times x plus 1. It's still exactly the same. We're multiplying the same 3 things together. Okay, so it doesn't really matter. All right, now when we go to expansion and a thing like this, what we're going to do is we're just going to focus on 2 of them to begin with. So we're just going to expand that part using FOIL that we're very familiar with. So that means in our first step, we're just going to have x take 3 hanging out the front, and we're just going to worry about the expansion here. Now you can think of it in terms of FOIL, but my advice is we take this term, and this term needs to multiply both of those. So we're going x times x is x squared, and then we're doing x times positive 1 is positive x. Okay, so we're doing that term times both of those. Then we move on to the second term, and we do the second term, which is positive 2, multiplied by both of these as well. So positive 2 times x, and then positive 2 times 1. Okay, so that's some pretty basic expansion. I hope we're pretty comfortable with that. The only extension thing that we would do there is now collect like terms. And so in the bracket there, what we have is we have x squared plus x plus 2x. Okay, they are like terms. 1 lot of x plus 2 lots of x gives me plus 3x. Okay, so we've expanded those 2 factors. Now we want to fully expand, which means now we want to multiply this linear factor by this quadratic factor. That's the skill we were drawing out yesterday, right? This is a linear because it has x to the power of 1. This is a quadratic because it has x to the power of 2. So what we did yesterday is I taught you that staggered procedure, and I would really like you to try and master that because it will pop up again today, and it has popped up previously in the test. So what we're going to do is we're going to take this term, just like we did above, and this term needs to multiply all 3 of these. So we just go in order very methodically, okay? Just think about it logically in order. The first term times the first term, x to the 3. Then we do the first term times the second term, x times positive 3x. That's going to be positive 3x squared. And then we do the last one, x times positive 2 is plus 2x. Okay, now you can keep going along that same line, but the staggered approach, what we do with that is we take this number, minus 3, and it needs to multiply all 3 of these, right? So we're doing minus 3 times x squared. That's going to be minus 3x squared. Now I'm putting it beneath this term because they're both the x squared terms. And when we collect them, it's going to be really easy for us to see what the like terms are. We then do minus 3 times positive 3x, that's going to be minus 9x, and minus 3 times positive 6 is minus 6. So now when we collect like terms here, we just add vertically. That's the beauty of the staggered method. X to the 3 is the only x cubed term, it doesn't have any like terms. We have positive 3x squared and negative 3x squared. Those are going to cancel. They will cancel each other out. Okay, so that's disappearing, and then we have 2x, take away 9x, that would be minus 7x, and take away 6. Now what we've done here is we've maintained equality the whole way throughout. So what I want to draw out is that this cubic equation here is the exact same as this one here, which is the exact same as this one here. There are all those ways we can present it, right? And isn't that fascinating? We have a cubic can be written as 3 linear factors, or a cubic can be written as a linear factor times a quadratic, or it can be written as a cubic in general form. Okay? So that's the first skill that they're going to draw out. Now, what we're going to do, now that we can expand, is we're going to do the opposite. We're going to start with a few cubics like this and go back the other way. We're going to factorize them. Now, we can't factorize all cubics. So this is our first example here. We can pretty easily factorize these ones though. The first thing that we're going to do is go, what is something that is common to all 3 of these terms? X. All of them have X. So we're going to pull X out the front, and that means in brackets we would have X squared, take 6X plus 8. Okay? Whenever we factorize, like always check, the way you know you're correct is if I expand this, if I were to distribute that X into this bracket, I would get exactly what I had above. X times X squared, X to the 3. X times minus 6X, minus 6X squared. X times 8, positive 8X. So we've factorized the X. However, the question says fully factorize. So that means we're going to look at this part, and we want to factorize that part there. That's a quadratic. We're familiar with factorizing quadratics. We want 2 numbers that multiply together to give us positive 8 and add together to minus 6. So they have a product of positive 8 and a sum of minus 6. And so you start thinking of multiples of 8. 1 times 8, 2 times 4. They both have to be negative because we have minus 2 times minus 4 gives you positive 8, but the sum is negative. So that's going to become X take 2, X take 4. Alright? And what we can start to see is that we've factorized this cubic. We can start to see the zeros, the x-intercepts, okay? They're the values that would make this function equal to 0. Well, 0, positive 2, and positive 4 would all make that function equal to 0. They are the zeros, the roots of this quadratic equation. So all we're doing in this exercise, we'll start with just doing some expansion. Okay, make sure we're comfortable with that skill, with the staggered approach. Okay, first we multiply the 2 linear factors, then we take the third one through. There's a bit going on there. And then we're doing the factorization, always pulling an x out and then factorizing a quadratic. So that's enough to get us started on question 1 and 2. That should take us up to recess, and when we come back we'll go through. What we'll do here, we're looking at this here. This is called the factor theorem, and we're going to be applying this today. We have if x is a is a root, then it means x take a is a factor. Now what we mean by factor, if we look here, this cubic equation is expressed as 3 linear factors. Factors because they're multiplying each other. And this was what you did in question 1a. You expanded that and showed that it was equal to this. So there are 2 ways of presenting the cubic. Here we can see what the roots are. All right, if x take 4 is a factor, all right, if x take 4 is a factor, then 4 is a root. All right, if we have x take 2 is a factor, then 2 is a root. All right, so we're going to use that to fully factorize this cubic. This is really the only way we need to know how to factorize a cubic that's written in general form. We'll always be given a root. We have x equals 2 is one of the roots. Now what that means is x take 2 is a factor. All right, if x equals 2 is a root, then x take 2 is a factor. And so my question is, what do we multiply this linear factor by? So we've got this linear factor times something to get this cubic here. Take 7x squared plus 14x, take 8. Does anyone know, what would we multiply a linear factor by to get a cubic? This has to be a quadratic. Has to be. ax squared plus bx plus c. One of the things we were trying to draw out yesterday is a linear, that's x to the power of 1, times a quadratic, that's going to be x to the power of 2. And when we add the powers together, we get the x to the power of 3. So we have a linear, and we have to multiply it by a quadratic. And so what we're going to do is we're going to find out, well, what are the values of A, B, and C that make it true? This is sort of a skill we were doing yesterday by equating them, and then fully factorize the quadratic. Okay, so the way we're going to process this is we have to expand what's on the left-hand side. We're going to fully expand it by first distributing this x. Okay, the first term needs to multiply all three terms. So we will get ax to the 3, x times ax squared. We'll have x times bx will give us plus bx squared. And x times c will be plus cx. Okay, so that's the first step of the expansion. Then the next step, we'll do minus 2 times every term in this bracket. Minus 2 times ax squared. Minus 2a x squared. And I'm writing it underneath this one because it's an x squared term. They're both x squared terms. Then minus 2 times bx. Minus 2bx. And then minus 2 times c will be minus 2c. Okay, so that's what it expands to. And then we're going to collect all of the like terms vertically. So this first one just stays as ax to the 3. This one becomes plus, and we remember we use brackets, and we do b take away 2a, and that's the x squared term. Okay, we have one lot of b, take away 2 lots of a, and that's times x squared. In the next one, we will have c take away 2 lots of b, and that's times x, that's the x term, and then we have minus 2c here. Alright, so the polynomial that we have expanded on the left-hand side is equal to this one over here. We're told that at the start. We know it's a factor. We know we have to multiply it by a quadratic. So it's equal to x to the 3, take 7x squared plus 14x, take 8. So then all we're doing is applying that method of polynomial equality. Alright, if this polynomial is equal to this one, then the coefficients of each term have to be equal. Alright, that ax to the 3 is equal to x to the 3. So a has to equal 1. Alright, that's our first equation. The x squared terms have to be equal. So what that means is b take away 2a, that coefficient here, has to equal the coefficient of x squared over here. So we can develop another equation. b take away 2a is equal to minus 7. Alright, the coefficient, the number in front of the x squared term here, has to equal the number in front of the x squared term over here. The same with the x term. We have c take away 2b, and that's equal to the x term over here. The coefficient of the x term over here is 14. Alright, so the coefficient there and the coefficient there. And then the last one, the constant term, we have minus 2c equals minus 8. So we have all of these equations, all which will share solutions, and we're trying to identify the values of a, b, and c. Now, from our first circumstance, when we equate ax to the 3 and x to the 3, we see a equals 1. So we've already determined the value of a. Now, I'm going to use that value of a in here to determine the value of b. Alright? We have b take away 2 lots of a equals minus 7. And so we'll process this. We'll have b take 2 is minus 7. We'll plus 2 to both sides. And we get b is minus 5. Alright. We can get c using this equation, or we can get it using this equation. I'm going to do both because I'm going to draw out that relationship that holds. We have b equals minus 5. So I'm going to put that minus 5 into this equation here. C take away 2 times minus 5 equals 14. Now minus 2 times minus 5, that's going to be positive 10. So we have C plus 10 is 14. Then we would take 10 from both sides, and we would have C is positive 4. And we can see that over here, if we have minus 2c is minus 8, we can divide both sides by minus 2. C is positive 4. Okay, so that equation reveals something we already found out in this equation. Now remember with this, you don't need to solve all of the equations. All we need is the values of A, B, and C. I'll just get this here quickly. Hello, Johnny speaking. Not this room, sorry. Okay, so we've found the values of A, B, and C. Now what that means, okay, I'm going to restate this path, okay? So that's going to become x take 2 multiplied by ax squared. We found A was 1, so x squared. We found B was minus 5. So it's x squared, take 5x. And C was positive 4. So that's the quadratic, all right? And we are asked to fully factorize. So there's one more step where we factorize that quadratic. Two numbers that multiply together to give us positive 4 and add to minus 5. That quadratic factorizes to x take 4, x take 1. All right, and then there's this x take 2 turning up the front. So what we have done, all right, we started with this cubic equation and we were told x equals 2 is a root. So we recognize, well, that means we have to write it as a linear factor. A linear factor has to multiply a quadratic because a linear times a quadratic will equal a cubic. We collected it and then we equated the coefficients in order to determine the values of A, B, C. Once we know what that quadratic is, we just have to factorize it. And so this cubic is the same as this equation here, is the same as this equation here. Different ways of presenting it. And again, like quadratics, they all tell us something different. We should start to be looking at that and going, I know what the y-intercept is. The y-intercept always occurs when x is 0. And then we can start to look at these. I can see the roots of this cubic equation. X is 2, x is 4, x is 1. Those would be the roots. Okay, so what I'd like us to do, turn the page over to 104, and let's start with question 3a. We have x plus 5 is a factor. That's what it starts with.